This is Math 83, Unit 3, Lesson 2. Here we're going to simplify an expression using the power rule. Well, in the lesson before, we saw if we expanded out x squared all to the third power, it would mean x squared times x squared times x squared. And using the product rule, we can go ahead and add those exponents and we would get x to the sixth power. And we can see here the quick, easy rule is to go ahead and just multiply the exponents, and we keep the base the same. So in number 2, we're going to keep m as our base, and then we're going to multiply 22 times 7, and we get m to the 154th power. We're going to keep the base of a, and we're going to multiply negative 2 times 3 and get negative 6. It's a negative power, so we're going to bring it down to the denominator, and it becomes a positive power. We're going to write its reciprocal. Keep the base of x, multiply negative 9 times negative 7, and we get 63. Keep the base of 4, multiply 7 times 3, and get 21. Keep the base of 5, multiply negative 2 times 2, get negative 4. We have a negative power, so we bring it down to the denominator to make it positive. And 5 to the 4th is 625. So we get 1 over 625. So our power rule of exponents for any non-zero real number x and any integers a and b, x to the a power all to the b power equals x to the a times b power. We're going to simplify an expression by raising a product to a power. This is a product inside of the parentheses, and so this means 7 times a to the 4th all to the 2nd, and the power on 7 is 1. So when we multiply the powers, we keep the base the same, so 7 to the 2nd power times a to the 8th power, and then we can evaluate 7 squared to be 49, a to the 8th. Inside the parentheses, we have a negative 6 times x to the 9th all to the 3rd power. That means we're going to take negative 6 all to the 3rd power, and then we can multiply 9 times 3 and get 27. We can evaluate negative 6 all to the 3rd power. That's negative 216, x to the 27th. No negative powers to move. A negative 5 is going to go to the 4th power. And then we can multiply negative 2 times 4, and that's going to be negative 8. When we evaluate negative 5 all to the 4th power, that's 625. And we have a negative power right here. So that negative power is going to come down to the denominator to become positive. 9 is going to go to the negative 2 power. And then p, we're going to multiply 2 times negative 2 and get negative 4. Now both of these are negative powers. So both of them are going to come down to the denominator. And it's going to become 1 over 9 squared p to the 4th, and then we can evaluate 9 squared and get 1 over 81 p to the 4th. Continuing, we have 5 to the negative 3rd power, and then we're going to multiply negative 3 times negative 9 and get positive 27. Here we have a negative power, so we're going to move that down to the denominator, and we're going to rewrite this as m to the 27th over 5 to the 3rd power, and then we can evaluate 5 to the 3rd to be 125. Here we have a negative 3 in front, so that's not being affected by the power of 5, so we're going to multiply that by m, and we're going to multiply 2 times 5 and get 10, 4 times 5 and get 20, and so we just get negative 3 m to the 10th and to the 20th. Keep the base of c, multiply 2 times negative 6 and get negative 12, multiply 5 times negative 6 and get negative 30. Both are negative powers, so both are going to come down to the denominator, and we get 1 over c to the 12th d to the 30th. We're going to take 2 to the 4th power, then we're going to multiply negative 3 times 4 and get negative 12, and multiply 2 times 4 and get 8. Here is our only negative power, so it's the only one that moves. We can evaluate 2 to the 4th, that's 16. We're going to move b to the negative 12th to the denominator, and it becomes a positive power, and we're going to leave c to the 8th in the numerator. So raising a product to a power for any non-zero real numbers x and y and any integer a, x times y all to the a power is going to equal x to the a power times y to the a power. Here we're going to simplify an expression by raising a quotient to a power. Everything inside the parentheses is getting squared, so y is going to get squared, and 3 is going to get squared, and that becomes y squared over 9 when we evaluate 3 squared. 5 is going to get cubed, x is going to get cubed, and because we have a power here on y, negative 2 times 3 is negative 6. We have our negative power here, so it's the only one that's going to move. We can evaluate 5 to the 3rd power. I could have put in parentheses. 5 to the 3rd power is 125, x to the 3rd, and we move y to the negative 6th up, and it becomes a positive 6. Negative 10 all to the 3rd power. We can multiply 5 times 3 and get 15. And we're going to take 3 to the 3rd power. Multiply the powers on b, so 2 times 3 is 6. And multiply the powers on c, negative 2 times 3 is negative 6. We only have one negative power, and that's this one, so that's the only one that's going to move. Everything else is going to stay where it is, and we can evaluate negative 10 all to the 3rd power is negative 1,000. A to the 15th stays put. 3 to the 3rd is 27. B to the 6th stays put, and we're going to bring up that c to the negative 6th up to the numerator, and it's going to become a positive 6. We have 3 to the negative 2 power. Multiply the powers on x, so 4 times negative 2 is negative 8. Multiply the powers, negative 2 times negative 2 is positive 4. And then on z, we have 3 times negative 2 is negative 6. Well, we have 3 that have negative power, so all of those are going to have to move. 3 to the negative 2 power is going to come down here and become a positive power. X to the negative 8th is going to come down to the denominator and be a positive power. Y to the 4th stays put, and z to the negative 6 moves up to the numerator. And now we can evaluate 3 squared, and we're going to get z to the 6th over 9, x to the 8th, y to the 4th. We can multiply the powers on m, so 2 times negative 4 is negative 8. Multiply the powers on n, negative 2 times negative 4 is positive 8. And then on p, we have 3 times negative 4 is negative 12. We have 2 that have negative powers. They're the only ones who are going to move. M to the negative 8th comes down to the denominator. N to the 8th stays. And P to the negative 12th power comes up to the numerator. Negative 3 times negative 3 is positive 9. We're going to take 3 to the negative 3rd power, multiply the powers on y, so 4 times negative 3 is negative 12, and negative 3 times negative 3 is positive 9. We only have negative powers here. They're the only ones that are going to move. So we're going to leave x to the 9th alone. We're going to move 3 to the negative 3rd power up to the numerator. We're going to move y to the negative 12th up to the numerator and leave z to the 9th in the denominator. And then we can evaluate 3 to the 3rd to be 27. Now raising a quotient to a power for any non-zero real numbers x and y and any integer a, x divided by y all to the a power is going to equal x to the a power divided by y to the a power. Here we're going to simplify and we're going to write an expression using only positive exponents, and I'd like you to try these problems on your own. So pause the video and do 21 through 28 on your own. Now check your answers for 21 and 22. Now check your answers for 23 and 24. Now check your answers for 25 and 26. And here you have answers for 27 and 28. If Jenna's age is represented by A times B and Ryan's age is represented by A times B times C, what expression represents the product of Jenna's and Ryan's ages? Well, product means times, so we're going to take this expression A times B and we're going to multiply it by the expression A times B times C. Well, the powers on all of these are 1. So we go ahead and add the powers and we get a squared, b squared, c.